Hello, I'm Emily, and today I will be explaining how to analyze the spectra for aspirin. So for mass spectra, we have the formula C9H8O4. The molar mass is 180, which right here at 180 is M plus peak. And then this tallest peak right here is going to be the base peak. And that's at 120. So to see if we can get any fragments, we're going to subtract 180 from 120, and that gives you 60, which doesn't give you any information. But if you look past right here, about 43, that fragment can either be CH3, CH2, 2, or CH3CO. And since we do have oxygen, that's going to be the fragment that we go with. Now, one more thing we have to do, the degrees in unsaturation, which is 2 times the carbons that we have, plus 2 minus the number of hydrogens that we have, minus the number of any halogens, and minus the number of any nitrogens, all over 2. Now, since we don't have any halogens or nitrogens, we don't have to worry about that. So we're just going to have 2 times 9 plus 2 minus 8 over 2, which is equal to 6. And what this number is the number of rings plus the number of double bonds will equal 6. Now we are going to look at the IR spectra. The IR spectra is going to give us a little bit more insight into what the mass spectra couldn't give us. So if we look at zone 1, we don't really have anything, any indication of anything. So we have nothing in zone 1. And in zone 2, it may look like we have nothing since there are no peaks going past that 50 mark. But right here is a carboxylic acid beard. Which is telling us that we're going to have a carboxylic acid in our structure. Now, if we look at zone 3, we don't have anything here as well, so nothing. But when we look at zone 4, this peak right here means that these two peaks actually means that we're either gonna have a ketone, a starch. Actually, this is a ketone stretch right here. But it also means that we could have an aldehyde or an ester. So that's all for zone 4. And now when we look in zone 5, right here, this peak, that's a benzene peak, which if we remember when we were looking at the mass spectra and we did the degrees of unsaturation, we know that we're going to have some rings in there. And double bonds as well, which is covered in the benzene peak. Now, not everyone looks at it, but right here, after zone 5, is the fingerprint region. And we do have some deep peaks that have come out here, and this peak means we may have some alkenes. This peak means we may have an ester or an alcohol, a carboxylic acid, or an ether. And then these two peaks as well mean that there are going to be an alkene in the structure. So now we are going to look at the H&MR. And I actually have the integration numbers right here for these peaks. So this integration number is 3. This one is 1, 1, 1, and 1. And from the small information that we got from the mass spectra, we know that we're going to have a fragment of CH3CO. And from what we got from the IR spectra, we know there's going to be a benzene ring, and ester, and a carboxylic acid. So let's draw the benzene ring. It has 3 double bonds. And let's draw our hydrogens for the benzene ring. Then let's put in our CH3 and then COH. Okay, so now we're going to look at the hydrogens. So integration of 3, it's meaning this group of hydrogens. So that's going to be right there. And that is at about 2.3. And now this group right here is in the benzene ring. So we have to figure out which peak is for which hydrogen. Now, this peak is the most deshielded, so it's going to be this hydrogen. So that is about 8.1. Let's connect that peak. And this peak is going to be this hydrogen. So let's connect that peak. And that's at 7.1. Now for these two, this one goes right here at 7.6. And then this last hydrogen goes right here at 7.35. Now we're going to look at the CNMR to see which carbons are which. So as you can see, I redrew our structure here. And let's label these peaks. Now you can't really tell on this one, but there's actually 2 peaks right here. So there's 1, 2. Here's 3. There's 4, 5, 6, 7, 8, and then 9. So now to figure out which carbons these are, we're going to look at these carbons right here because these are the most deshielded because they're both double bonded to an O as well as to that single bond. This one is going to be 1, that carbon, and this carbon is going to be 2. So let's connect those 2 right now. Here's 1, and the other one is 2. And if we look right here, this carbon is actually the least deshielded. So this one is going to be 9. And now we have to look at the carbons that are in the ring, because that's what these carbons are right here. So let's see. Number 3 is going to be this carbon. So let's connect that in there. Number 4 is going to be this carbon. Number 5 is going to be this carbon right here. 5 right here. Number 6 is going to be this carbon right there. 7 is going to be this carbon up here. And then the 8th carbon right here is right there.